So today is the last lecture of that a 5-lecture series on AI for good. So to give you like an overview of how AI can be applied to many to these sustainable development goals, right? How they can help humans, animals, vegetables, and everything on this planet. So this last lecture is about nature. So nature is vast, right? So we're going to do an overview in less than 1 hour. It's mostly land and what we call land ecosystem and marine ecosystem. So land, seas, and water, seas and ocean. So this is lecture 5, where we've seen poverty, hunger, cities and communities, energy and nature, and all these lectures are recorded, so you can watch them later or share them. So the outline, I won't go over the Sustainable Development Goals again, right? Because we've seen them like each lecture. I'll jump straight to the state of nature ecosystems. The SDG targets. SDG stand for Sustainable Development Goals. How to protect nature ecosystems. How AI can help to protect these ecosystems. Go over some case studies, and I will conclude. Okay. So first, land, and this is just for your reference, is what they call SDG number 15. Right? There are 17 goals, and this is the goal number 15. So since the Industrial Revolution, right, the 18th century, nature was just a passenger, right? We went through the Industrial Revolution without too much regard for the state of nature. Even though nature is a source of raw materials, fuels, fresh water, soil, food, forests, has provided invaluable ecosystem services, so climate, air quality, fresh water, ocean acidity regulation, even CO2 regulation. It has deteriorated under our stewardship. Nature has been domesticated with resource extraction, deforestation, human land use change, agriculture, urban development. It has resulted into loss of biodiversity, natural habitats, air pollution, water pollution, soil pollutions. So they all show like a severe impact of our activities on nature. This is just a picture of all the type of land that you can find. It's very diverse, but they all of them are impacted. The IPBES has it's a national organization that look at diversity, nature, and so on. So the experts of the IPBES have recognized the vital role of nature in providing ecosystem services, function and services to humans. And they have noted that it has been deteriorating, especially in the last 50 years, right? Unless we do something quite drastic, to reverse these trends. So do you have some like goals that for 2050, these goals called like Vision for Biodiversity are not going to be met. So natural habitat has declined, right, with human development and exploitation of natural resources. Agricultural lands, human settlements, towns, cities have encroached or replaced forests, grasslands, and other natural ecosystems. Lakes, rivers, wetlands, coastal areas are all affected by human activities, especially by pollution and contamination. So as a result, by biodiversity, a number of variety of animals, plants, insects are shrinking, and they're replaced by crops, livestock that are much less diverse. Right? All disappearance of like natural species have like sometimes unpredictable like consequences, right, on the food chain, like on the prey, predators, and so on. So we all these species disappear, and we don't really know the long-term consequences. So as we said, that land has been used for agriculture, clear for forests, replaced by crops, animal farming. So big loss of the biodiversity, but also CO2 absorption capacity. Right? Deforestation and forest degradation continue in favor of agriculture. So there are, according to the FAO, there are around like 4 billion hectares of forest in the world. Only 1/3 is a primary forest. So it means like untouched by humans. So 2/3 are like already touched by humans, exploited by humans. Section is talk about desertification and land degradation. So our expectation of soil, water, and vegetation has led to desertification and land degradation, right? As you remove all the trees and you plant only one type of tree. It's not good for the soil. 20 to 40% of land is degraded because of unsustainable land use and economic growth model that favors extraction of natural resources rather than nature conservation. So this is not surprising, but it's so now we talk about land. Now we talk about marine ecosystem. So oceans. We had one presentation about on ocean, on the carbon cycle, right? Before. So oceans play an essential role in regulating the climate. So they produce half the oxygen, absorb the CO2, maybe 1/3 of the CO2, and cools the planet. It brings immense economic benefit to humanity, and it is estimated to contribute maybe $1.5 trillion per year to the world economy. More than 200 million people work directly in the food production from the oceans, and estimated 3 billion people are consuming it. Coastal areas are homes of many people and provide them with essential ecosystem services, such as fisheries, the biodiversity, water and climate regulations, natural protection from sea level rise. This is an interesting map. So just look at the world map. So in green, you see the continents, and then you see the seas and oceans in different colors. And this is an index. It goes from 0 to 5. It measures the cumulative human impact. Right? So it's a combination, I think, of 14 stress factors. So if it's like dark red, it means that it has been heavily like impacted by humans. If it is like the blue, has been like more like untouched. Right? So you see, so the US is here, right? It's North America, and Europe. This is like the Black Sea. And you see that it has been, it's really, it's more like a Dead Sea, right? It's heavily red. Usually in the North Atlantic, it's pretty red, so it's pretty bad. The impact of humans is pretty bad. And in the Pacific, around the equator, where nobody lives there, so it has been more like untouched. So climate change is affecting the oceans and contributes to their warming and acidification. Right? Coral reefs are very exposed to the rise in temperature. Right? So the disappearance also causes losses of biodiversity in the coastal areas. There's also unknown and unpredictable consequences for life in the oceans. Something that is can directly observe, like plastics. We have also heavy metals, chemical pollutants, contaminated water, and sicken marine life and food chain in the oceans. Microplastics. Now people are very interested in microplastics. So tiny plastic particles up to 5 millimeters in size, and are found in large quantities in ocean water. Often close to coastal areas, they're ingested by fish, marine animals, and indirectly by us too when we consume this fish, with uncertain consequences for marine health, but also human health and the environment. Oceans are a source of food, with 80 million tons of fish captured every year. Increasing fish consumption, increased population, but they of course suffer from overexploitation due to illegal and unregulated fishing. Right? So sustainable fish stock has fallen from 90% in 1974 to only 65% in 2017. So sustainable means that we don't fish. We don't fish to the extent that the population doesn't renew itself. So you know that all these sustainable development goals have targets associated with them. So the goal 15 is to protect, restore, and promote sustainable use of terrestrial ecosystems, sustainably manage forests, combat desertification, and halt and reverse land degradation and halt biodiversity loss. Here, I won't go over everything because I mean this time we talk about land and ocean, so it's a lot on our plate. But these first three targets by 2020, it was 2 years ago, right? Ensure the conservation, restoration, and sustainable use of terrestrial and inland freshwater ecosystems and their services, in particular forests, wetlands, mountains, and drylands, in line with obligations under international agreements. Target 15.2 by 2020, promote the implementation of sustainable management of all types of forest, halt deforestation, restore degraded forest, of substantially increase afforestation and reforestation globally. Third target by 2030, combat desertification, restore degraded land and soil, including land affected by desertification, drought, and floods, and strive to achieve a land degradation neutral world. Right. So we know that we are far from that. Right? You see like wildfires on the West Coast and in Europe, flooding in Pakistan. So, you know, these things are not great, and we are going to see that they are not that great. Let me skip this. This goes. So how are we doing, right? So here you can go. So this for that goal, like life on land. So if you go to the website, there's a website from the SDG Index. They try to quantify, you know, how far we are from reaching these goals. So life on land, SDG 15. So here we can see the world map in the two views. One in terms of ratings, also the index. So you see on the left hand side, you see the legend. So green means that it'll be achieved. Right? So if everything is green, it means that no, that's it. We made it. We did it. Yellow, challenge remains. Orange, significant challenges remain. Red means major challenges remains. And gray means there's no information. And you see that the map is mostly red. So major challenges remain. So it's kind of at the bottom of the scale, right? It's gray, that means you have no information. But we're not doing great, right? And in terms of trend, are we improving or not? So we are between orange and yellow. And you see on the left-hand side, on the high left-hand side, we are moderately improving in yellow area, so in Canada, you know, and in Western Europe, in Russia, stagnating in many of these areas. In China is stagnating and decreasing some areas. You know, like usually you really expect maybe poorer areas is where it's kind of decreasing. It's not the top priority. So marine ecosystem. So here again, I'll just go over 3 targets, right? And conserve and sustainably use the oceans, seas, and marine resources for sustainable development, right? So target 14.1 by 2025, prevent and significantly reduce marine pollution of all kinds, in particular from land-based activities, including marine debris and nutrient pollution, right? Target 14.2. By 2020, sustainably manage and protect marine and coastal ecosystem to avoid significant adverse impacts, including by strengthening their resilience and take action for their restoration in order to achieve healthy and productive oceans. Target 14.3, minimize and address the impacts of ocean acidification, including through enhanced scientific cooperation at all levels. Just to give you an example, like in the UK or even in the US on the East Coast, it's common knowledge that you shouldn't take a bath, shouldn't go take a dip in the ocean when it rains, or even 1 or 2 days after it rains. Right? Why is that? Because you have overflows, right? Overflows from the wastewater system, right? So it's flowing into the ocean. So then the water is extremely contaminated, right? You can even get sick with bacteria or so, right? So when you have like heavy water, a lot of rain, a lot of flooding, it's very you shouldn't go into the ocean or the sea, right? And it is like true like in many areas. So let's skip this. So how are we doing for the marine ecosystem or life below water? So here also you have the rating. So here maybe you should use these red and orange pictures. So here also it's a lot of like red. I mean, you see like these gray areas because they don't touch the seas and ocean. Right? So there's no data to collect really. So, but otherwise, you see a lot of red. Major challenges remain, right, to preserving the seas and ocean. Or it's orange. I see significant challenges, right? And you don't see, I don't know, unless I'm mistaken, you don't see a single like green area. No country has achieved their SDG target. The trend, most of it is orange, right? Stagnating. So we are not stagnating. Remember, right? These goals are by 2030. So it's in 8 years, right? We also passed some goals that were supposed to be met in 2020, right? So we didn't meet them. And we have goals for 2030, but everything is stagnating. So not very optimistic. So how to protect land ecosystem, right? Some of these reports, when you read them, they have some good ideas. Some of them are like more like wishful thinking. It's not clear how they can achieve that. But I mean, these are ideas, right? So, for instance, the FO is proposing adopting inclusive land and water governance, right? So collaboration and shared governance between stakeholders and sectors, developing coordinated and coherent policies and approaches by avoiding fragmentation and power imbalances, right? Because you have like a lot of stakeholders, stakeholders, right? You have landowners, farmers, people who control the water, farmers, agriculture, the environment, people who control the money, right? The governments and so on. So they might all have like different objectives. Other ideas, implementing integrated solutions at scale. So like you should do it in a coordinated way and integrated way. It's probably not easy in practice. Embracing innovative technologies and management, right? So these are all like good ideas. And I think you see a lot of AI applications in that. So sustainable soil management, rain-fed agricultural production, right? So don't use water from underground, but use the rain. Better water productivity, don't waste water, right? Harvest rainwater, better use water efficiency, water accounting and auditing, right? Monitor your usage, modernizing irrigation systems, better water storage, protecting groundwater, limiting pollution by nutrients and fertilizers, reducing the use of pesticides and contaminants, reducing the salinity of water and soil, more research in crops and biotech, adopting ICTs, communications and technologies and big data, reducing food loss and waste. I think like 40% of food produced is wasted, right? It's not consumed. It's huge, right? It's 40%. Promoting sustainable diet and the circular economy. Investing in long-term sustainability, right? So here, like, to include more climate financing, for water, agricultural, land projects, all these things require money. So all these ideas will need to get implemented. Have more equity in irrigation projects, innovative and responsible projects, and resource management and governance with better data, communications, and technology, engaging farmers in the land, water, agricultural sustainability efforts. Let's talk about diversity, but we'll talk about this again. So how to protect marine ecosystems? So a lot of it is contrary to land, a lot of it is like to understand and research. Why? Because we don't understand everything about the seas and oceans, right? So they still, I think for land, we invested a lot because it's just there and, and we need food. So we invested a lot, right? But to understand the oceans, it's the research is is far behind, right? So now what they suggest, understand the stressors, what causes stress in the ocean ecosystem and biodiversity, right? What the role of the ocean plays in feeding the world, right? And the ocean climate nexus, right? How does the ocean help to address climate change, right? So all these things are very useful. Building early warning systems for all ocean and coastal hazards, right? To prepare communities on their resilience. Challenge 7, ensure sustainable ocean observing system. So we need to be able to observe the systems, right? The oceans, and possibly in real time, right? So we know what's going on. Challenge number 8 is very interesting for AI, experts. Develop a comprehensive digital representation of the ocean with free open access for exploring, discovering, and visualizing ocean conditions, right? So you want to be able to digitally represent the ocean, right? So you can monitor all the flows and what's going on in there. And ensuring equitable access to data, information, and knowledge and technology, right? So that anyone who wants to do research in that area could do it and have the tools, data, and resources. Okay. So how AI can help, right? So I will give you so you see a lot of issues to solve, and AI can definitely help. So I'll give you some general ideas, and we go over some 3 case studies towards the end. So for land use, so AI can help monitor and predict and classify land use, and we see an example of that, right? From satellite observation of sensors, right? So you use the forest, you use for crops, you use for farming, and so on. AI can help for crop yields on health, right? Assess the crop yield. So we've seen example on the lecture on hunger. AI can predict water and soil nutrient quality and efficiency, right? So all these things are through satellite image. AI can help identify human settlements, disaster zones, drought, flooding areas. It can monitor water cycles, water evaporations, motion of clouds, and predict rainfalls. It can help for the carbon cycle. Right? It can help to monitor biodiversity and species at risk of extinction. And we're going to give you an example of that. And AI can monitor the temperature, right? So large fluctuation of temperature. So you live in the West Coast, right? In the past couple of days, you have crazy temperature, right? 108, 110 in San Francisco and its surroundings. So AI monitor satellites, and AI can monitor this in real time, right? While forest fires too. For marine ecosystem, so here also, thanks to remote sensing and on satellites or on floating devices, right? Can help the prediction of the impact of climate change, sea level rise, impact on coastal system erosions. These floating devices have sensors, as you can measure ocean salinity, acidity, and so on. So you can collect useful data. There could be an early warning system used for disaster prediction, such as underwater earthquakes, typhoons. So using satellite images and weather data, tsunamis, using ocean sound waves. So some application of that. AI can help predict pollutions in the effluents on large marine ecosystems, also from plastic and microplastics in the oceans. AI can help monitor and predict the risk of oil and chemical spills from ship containers and all the offshore drilling platforms. AI can be used to monitor biodiversity and identify marine species and fisheries activities. In terms of coordination, AI can help coordinate resources from land, forest, and biodiversity conservation and restoration by identifying the factors that can cause degradation. AI can help plan for the consequences of crop failures and natural disasters. AI can identify and guide resources to reach vulnerable human populations. AI can coordinate efforts to fight against illegal poaching and illegal land use, right? Because we can monitor the data and see what's happening. For marine ecosystem, AI can identify factors contributing to pollution and contaminations of the seas and oceans. AI can assist in localizing and identifying ships on the oceans, provide guidance and navigations to ensure safety of the crews, passengers, shipments, vessels, and the ocean. Optimization, AI can help to optimize the use of land inputs such as fertilizers, irrigation systems, type of crops, maximize the crop yields, alternative land use while being sustainable. For forest, AI can optimize the characteristics of trees to cut and to ensure the replenishment of future trees. AI can help optimize local animal populations to keep a healthy balance between prey, predators, and a full ecosystem. Marine ecosystems, AI can help navigation with computer vision on satellite, better geolocation, and to optimize shipping routes of ships. AI can optimize the sustainability of fisheries in certain maritime areas and monitor the fish population and predict its dynamics and replenishment. On land, right, so control, this is the last part. So this is the PICOP framework, right? Prediction, coordination, optimization, and control. This is the last part, control. So when control is when the AI acts by itself, right? So autonomous AI can help navigate agricultural machines, right? So they can like farm and harvest by themselves. They can help feeding, managing, caring for crops or livestock animals, right? And they can do predictive maintenance for farming machinery. Right? You can control irrigation system, right? In closed environment, you can control everything. You can control, in a greenhouse or vertical farming, you can control all components for precision farming. So you can see the exact amount of chemical, fertilizer, water, and so on you need for the plants. Right? For marine ecosystems, so we thought like autonomous cargo ships. This is coming. Peasant ships, scientific ships, right? So for very scientific exploration, it's easier. There's no humans on board, right? You can send them for a long time. You don't need food or anything. For especially in extreme oceanic areas or the poles. So also we could have also like a permanent presence of AI piloted devices, right, at sea, right, on the in the poles, for instance, right, to monitor what's going on. Right? So we don't need to rely on scientific expeditions. So if you could have like these devices, taking measures, doing like AI computation on device, or sending the results to satellite and to us, we could make a lot of progress. Right? So there's also issues of safety and so on. So case studies. So I'm going to go over like three interesting case studies, but there's a lot, So I put some resources, and you see there's also like in these prediction, coordination, control. You see like many ideas, so you can see what is of interest to you, and I'll focus on that. So first example is a Dynamic World. It's a product made by Google. It's about land use, about classifying land use. Second example is about to assess extinction risk, right, of animals, insects, plants, and so on. Third example is about fish tracking. Okay, so how do you fish track or monitor fish in the water? So Dynamic World, there's a website you can do. It's a free access. It's a real-time model of global land use and land cover use, right? What does it mean, land use, land cover use? It means that you want to know what is on the land, right? Is it like crops? Is it like is it plants? Is it forest? Is it lake? Is it lake? And so on. So you need to know. You want, first of all, a lot of applications. You need to know how the land is used. What is a land cover? So historically, it hasn't been done before, but not in real time. So maybe it's done, once a year, depending on some areas. So there are a lot of lags in this data. So what is remarkable about this is that they do it in almost real time. Right? So it's using satellite imaging from Sentinel-2. It's the name of like a satellite, like 2 satellites. and is using Google Earth Engine. So Google Earth Engine is a great platform for people who do like GIS research, and they're interested in maps and so on. So use on Google Cloud for storage to produce land use and land cover data at high frequency, high resolutions, in a globally consistent fashion. Right? Because sometimes the land use is done by some researchers interested in some areas. It could be sub-Saharan Africa, and they wouldn't look at Asia or North America, Canada. So, and other researchers would look at these other areas, and very often they wouldn't be consistent. Classification would be different, and so on. The coding would be different. So here, at least, is everything is consistent. So they use as training data, so Sentinel-2, so level 2 surface reflectance imagery data. So you see that plants, water, and so on, they reflect light differently, right? So depending, infrared, visible light, on some are reflected differently by this land cover, and then you can use that to identify, what is on the land, right? So you see so this color. So these are results of a dynamic world. Right? So it is remarkable. You can the whole. I mean, it's almost, I don't think it's 100%, but I think most of the planet is covered by that. And you see the classification that they have, legend. You see, so we say water. So it's blue is water. Green is trees, light green is grass. Then you have flooded vegetation, right? So it's useful to know, right? Kind of flooding. So how much of the vegetation is flooded? You want to know in real time. So for instance, you could look at what's happening in Pakistan. There are a lot of flooding. Say that. So how much of vegetation is flooded? Crops, right? Shrubs and scrub. Built environment. So if you do the picture of Manhattan, it's all red, right? There, there's nothing there. And snow and ice too, right? If snow and ice purpose, you look at the polar poles, so you see if the disappearance of ice, which is a big concern, you can monitor it in real time, which is remarkable, right? You can see, like week after week, month after month, how is the snow cap also disappearing, right? So you can do it for free on the dynamic world, right? So this is so what they do. So a lot of machine learning and AI is done on supervised learning, right? So they have so I've mentioned the nine classes, and they use human annotators, right? They look at these images of satellite data, and they say what it is, right? They give the answer, right? So they have experts in photo interpretation, and they're assisted by non-experts, right? And they give the label. They're 50 meters by 50 meters label, right? So they use that as a training data, right, to train the model, and the model is that trained on this data. Then you can classify data the images that it hasn't seen before. So in practice, it can process. So these images are huge. Right? That's why you need cloud storage usually. This new Sentinel-2 images, they do it in 45 minutes, and every 14 seconds they produce new results. Right? It's updated every 14 seconds. Right? So it's a lot of information, right, for a lot of scientists, researchers, or normal citizens about water usage, evaporation, flooding, urban expansions. Or you can see the built environment, right? You see the cities expanding or shrinking. Deforestation, right? Because if it's a forest, if it is crops, right? So we can look at Brazil, look at the Amazon, right? Is that the forest being replaced by crops, right, or by farming, right? And the state of glacier too, right? We talk about the ice and snow. So this kind of big deal. Next example is extinction risk. Well, we talk a lot about biodiversity for land use. There's a website. This is also free access of the IUCN. Forgot the name, but we'll see maybe on the next page. It's the International Union or something called conservation to assess the extinction of species based on the red list. Okay, so it's here, International Union of the Conservation of Nature, right? So this is the red list. So in the past, that's done kind of manually. This is the website, right? And they have so each species, right? There's an inventory of a species, and they classified into 5 categories. Least concern, that we're not concerned by because holy, right? Holy is not endangered, right? Near threatened would be NT, vulnerable VU, endangered EN, critically endangered CR, right? So it'd be the worst. So for instance, here the example is like taken a few days ago. It's like this like small fork, critically endangered, right? This tarantula too. Right? So you have like thousands of species in there. These researchers, they here too. These are something. These are so you have a website or so that tells you the number of occurrence, right, for a given species. So people report, right? So I think this is done like I think everybody can participate. They probably say how many of the species you have observed in your area, right? So these are where so these are the occurrence. So this is so this occurrence of this this particular plant, right, on Troceroto data. So you see that has been seen a lot in in this area and a few in this area, right? So this is so then they use like 2 types of in fact, four types of machine learning models. You have the CNN, convolutional neural networks. So this is used for images, neural networks, right? And we have an approach by classification or by regression approach, right? So regression would be to predict a score, right? This is a numerical score. A classification would be, like the endangered species, yes or no. So the features that they have used could be like the position, right? Region, where is it, right? Number of occurrences, right? And so this kind of data can then have climate variables, footprints, or so as features. So why do you have geography? Because suppose you're in the middle of the Amazon, right? And then there's a big effort of deforestation, right? So if you see that, then it's very likely that that area, all species are going to be impacted. So it's very longitudinal latitude, the position will be a big factor. Right. So in the paper that I cite, they applied to orchids, and they find that it works pretty well, at least for the binary classification, threatened and possibly versus possibly threatened. Right. The last one is about the oceans. So here, fish tracking. So you want to see, because we talk about a lot of overfishing, but how do we know that there's overfishing? So we have to count the fish, right, in the ocean. This is our ocean. You have to monitor them. That means you have to try to count the fish, but see what type of fish, right? Because you might overfish one type of fish and not another type of fish, right? So it's important to, this is important, of course, to maintain a healthy a marine ecosystem. So here they developed a model to detect, classify, and count fish by species using high-resolution visual sonar, underwater videos, and deep learning. Right? The old way of doing it is to catch the fish and tag them, right? Or do catch and release, right? So this is actually, so you see, that's not really, I mean, it's what people have done, right? So that kudos to them, but it's very labor intensive, right? It's and then you have to do some statistic, extrapolate on some, right? So, but it's not, it's hard to do, and you cannot do it all the time, right? And some species, you're not allowed to tag them. You're not allowed to catch them too, right? It's a big problem. So how do you monitor these fish? So here, so what they suggest, so these high-resolution sonars, so they can help monitor the fish behaviors. So they're sending some pulses, right? Like the principle of sonar, right? Like for submarine too, something, and they convert the echoes into images, right? So the advantage, you don't touch the fish, right? So they also work well in dark and murky waters. So it's not optical. So one's there's no because it's like a sound wave. Right? So sound wave doesn't care about the light. Right? So very deep under the sea, it still works. So they have this. So I'm not expert, right? So I'll just tell you the simple introduction. But the product that they use is called DITSON, a dual frequency identification sonar on ARIS. adaptive resolution imaging sonar. And you can Google it and learn more about this. So these are like images from a Ditson sonar. Okay, so it's not super clear, but you can see, on the left-hand side, you see salmon. So here they want to detect salmon. So in fact, here you see like 2 salmon. In fact, it's a video, so it takes videos too. So just 2 like snapshots. You see two salmon here crossing, and here you had another salmon on that area, right? So you can see that it's not hard to imagine that you can a system, you capture images and you count, you try to train to recognize the AI to recognize the salmon. So this has to learn that it is a salmon, right? And with label data, right? So experts have to teach the AI these are the salmons, right? And then the AI will learn from it. Right? So the way they do it, they use 100 hours of high resolution visual acoustic Ditson videos. So the same thing that you see in videos, right? Like they did in the river in Michigan. And they have fish experts who annotate these videos, right? So they need experts, right, to give the answer to the AI. And they also do with optical videos, optical footage close to a dam, right? The dam is very closer to the surface, right? So they evaluate like three models. I won't go too much into details, but you should at least know the name of these models. You have for object detection, right? You have to see before classifying an object, you have to know, is there an object there? So is there a fish there? So they have to use what they call object detection model. So you have what they call YOLO, the YOLO models, called like you only look once, right? So I'll put the reference here. And mask RCNN, so mass region-based convolutional neural networks. There's also a kind of neural networks, but has the power of like giving a mask. So the mask means that if you have the fish on the picture, it can give you the frontier of the fish. Right? It can tell you where the fish is. So it's not only a box. YOLO will tell you a box, right? And object detection will tell you a bounding box, right? Mask, and give you a confidence score. We'll see. Okay, okay, what this is. So this is what the YOLO will give you, right? It tell you, okay, there's a box. It tells you on the picture, on the image, where's the fish, right? The many fish, you have seen many boxes. I tell you, this is a fish, 95%, right? And if it's trained on the type of fish, it will tell you what this is a red snapper or something, right? So there are challenges. They have to clean the images. They have very often they don't have enough images, right? So they have to create they have to create like new images from the old images, and they can do rotation and so on, change the shape and so on, to create like more training data, right? So they find that it works pretty well. So you can imagine the system. You can have a sonar, put it next to a dam, in a river, on some location, right? And you can maybe like put sonar everywhere, right, in the oceans, and count the fish. You have such like a great idea of what's going on. For instance, today we see fish appearing, or even sharks or whales appearing in some areas that we have no idea where they're coming from, right? So if you have these sonars installed, like everywhere, covering the whole all the seas and oceans, you have a very like precise like ideas of the population, the fish population. So conclusion. So we see that nature, land and marine ecosystem, they play a vital role, right? For us, and this nature provide ecosystem functions and services. But it has been getting worse in the past 50 years, probably because humans, we know priorities on humans, right? We talk about health, hunger, and so on. These are also big problems to solve. So maybe in the nature is like the last week. And we've seen the progress are not great, right? We have passed some deadlines like 2020, next like 2030 in 8 years, but it doesn't look great. So unless we do something dramatic, it's not very optimistic. So AI can help, right? AI can help, right? Potentially, right? Can help protect land and marine ecosystems. When we talk about prediction, coordination, optimization, and control, so there's still a lot of ideas, and I hope that maybe one of you, some of your friends, colleagues, and so on, will be interested in working on it. So I saw like three case studies: dynamic world, extinction risk, and fish tracking. But as you know, people are getting more familiar with AI, AI, machine learning, you get more data. I think dynamic world that came out only a few months ago. So you have a lot of data available. Sonar data is pretty new. But then you have a lot more data available, and then you can use the AI tools to make sense of that. Okay. So so this is so this so all these things is covered in my book, so coming out in 3 weeks, October 1st. So we see that so this chapter. So you have like 17 goals. So lecture 1 was about poverty reduction, right? And that's the first chapter of my book. Lecture 4 was about energy. I didn't talk about health because we had a speaker who talked about health on AI already. There's some typos here. Then chapter 9 and 10 are about land ecosystems and water ecosystems. This is what we covered today. So I haven't talked about sustainable economy, industrialization and innovation, infrastructure, peace and justice, partnerships. I mean, it would be like too many lectures, but it is all in this book. So I encourage you to have a look. So if you have any questions, please raise your hands, and you can ask the questions. Otherwise, I stop here. Okay. And the next speaker will be so next week there is a speaker, but has not confirmed yet, so I'm not sure. Great. Okay. Yes, great. Yeah. Okay. I don't hear. Okay. So I don't know. I cannot hear you. But okay. And then next end of the month, we'll talk about consciousness on AI. It'll be very interesting with the professor from Columbia. Okay, so thank you very much, and thanks for attending, and there'll be a recording soon posted on the website. Okay, bye-bye.